Okay, I had a student. I forgot I had a student had a scheduled appointment at 2 o'clock today, and that interruption. So anyway, go watch this. Go watch the videos. All right, go watch those two videos, and it'll answer some of your questions. So let's just start off. I'm going to start off this one. Let's just go to these slides that I've made here. Okay, and here they are. Here it is. There's 5 kinematic variables. There's displacement, that's the distance we travel. There's acceleration, which we will keep constant. There's the final velocity v, an initial velocity where we start, or that might be where we stop. Okay, sometimes, and then the time. And then here's the 4 little equations that we use for them. Now that looks scary, but it's really not that bad. It's really not that bad. And I'll walk you through any problems where we've got to use these guys. We'll have walked through 2 or 3 of them, and then you'll get one that's not exactly, the numbers will be different, but it'll be just like what we did. Okay, so it's not a big deal. So let's just go ahead and look at let's look at the mini lesson homework here real quick. Mini quiz. Let's look at the mini quiz 7. So let's start it. Now, if you're watching this without having watched the it might be okay because you get three attempts to go ahead and take a look at this, and then first, and then you'll know what you're looking for when you're watching the things. You can write some of the answers down and then come back. So to get things started, since we're talking baseball, a game invented here in the U.S., we will use feet per second for our speeds. Okay, we'll look at knowing that there are 5,280 feet in a mile and 3,600 seconds in an hour. Convert 15 miles per hour to feet per second. How the heck would you do that? Okay, well, let's just take a quick peek at how we would do that. And here we go. So question 1. So this is mini lesson 7. All right. So I've got 15 miles per hour. So what do I need to do? I need to figure out a way to get rid of the miles. So I'll put miles down here. But I need feet up here. So how many feet are in a mile? We already talked about that. And then multiplied by, I need to get rid of the hours down here, so I want to be able to cancel it there. And we know that there's 3,600 seconds in an hour, put it in the feet. And so we come up with a conversion factor of 15 miles. This is the way I like to do it. And I take the 5280. Well, now that I've told you how to suck eggs, here we go. Sorry about that. Feet per second. See, look what we did. And I know that this gets rid of the miles and things like that. Okay? And it came out to be a kind of a cool little conversion number of 5280 divided by 3600. 1.47. So this equals 1.47. So anytime I ask you in the future to come up with your feet per second conversion, okay, so 1 mile per hour equals 1.47 feet per second. There's your conversion. So you can just take 15 times that if you want. All right, I kind of went around the bend on that, but it's okay. How many feet are there between first and second base? If you don't know, you can look it up. You can Google that one. Okay. All right. In the base stealing video, the runner went from first to second base in 3.5 seconds. Using your calculation for 15 miles per hour to feet per second, in other words, what you did in question 1, how many feet from second base was he when he started? It'll be not one of these numbers because he had a lead off. We are assuming this is the runner's average speed. You have to throw that in when you're a physics teacher just because students will get, just to make it right. So for question 3, you take the answer from 1, one of my favorite things to do, and he's 3.5 seconds. So how far did he go? Well, we've got an equation for that. X, and here's the fifth equation. If there's no acceleration, we're assuming no acceleration here. Okay, we could use this one too. This is a nice one. This is a nice equation. So let's go ahead and use this equation. All right, let me show you how to use it. So for problem 3, we can, you could use the distance equals rate times time. So you have the rate, you have the time, multiply those together and you got the distance. But this other one where you have x, it's the same thing as this. This is just the fancy physics way of doing it, where we'll take since we're assuming no acceleration, then we just take, well, it's equal to v times t. Okay, that's it. We'd use this equation without the acceleration, where we get x equals v times t, since we're not having any acceleration. Now there's a huge acceleration when he starts to slide, and there's a huge acceleration when he takes off, those kinds of things. All right, so let's go ahead and stop here.